Enhancements of human milk oligosaccharides may help improve gut well-being in grown-ups. Enhancements of human milk oligosaccharides, HMOs, the sugars found in bosom milk, may help improve the gut well-being of grown-ups, as indicated by new examination did at the Quadram Institute. Utilizing profoundly progressed, gut-on-chip innovation, they showed that the maturation results of HMOs made the gut lining less broken. A flawed intestinal boundary has been connected to gut conditions like celiac illness, Crohn's infection, and peevish inside disorder, just as a scope of conditions influencing the remainder of the body. This investigation gives logical proof that HMOs might be utilized to foster techniques to counter these conditions and improve gut well-being in grown-ups. Human milk oligosaccharides, HMOs, are mind-boggling toxic sugars normally present in bosom milk. They are especially fascinating, a direct result of their amount and underlying variety, which supports different advantageous advantages to the well-being children. They are notable for their prebiotic impact in babies, where they fill in as nourishment for intestinal microorganisms, particularly bifidobacteria. The strength of these intestinal microorganisms in the gut guarantees a sound intestinal microbiota and diminishes the danger of hazardous intestinal contaminations in newborn children. Notwithstanding their exhibited advantageous job in newborn child well-being, a new clinical preliminary showed that 2 explicit HMOs, 2,O-fucosilactose, 2,FL, or potentially lacto-N-neotetrose, LNNT, are protected and all-around endured in grown-ups and are modulators of the grown-up gut microbiota with an expansion in bifidobacteria. This recommends that HMO supplementation might be a significant system to balance well-being in grown-ups. In any case, the effect of HMOs on the gut obstruction work has been generally underexplored. To address this, a coordinated effort was set up between the Quadram Institute, a food and well-being research focus on the Norwich Research Park, UK, and Glycom, a Danish-based biotechnology organization and world's driving provider of HMOs. Their investigation, distributed in the diary Nutrients, was halfway subsidized by the Biotechnology and Biological Sciences Research Council, BBSRC. A simulator of the human intestinal microbial ecosystem, SHIME, was utilized to decide the impact of HMOs on the grown-up gut microbiota arrangement and capacity. These trials were performed at ProDigest, a side project organization from the Center of Microbial Ecology and Technology, CMET, situated at Ghent University in Belgium. The outcome showed that aging of 2,FL, LNNT and blends thereof prompted an expansion of bifidobacteria, joined by an increment of short-chain unsaturated fats. Professor Natalie Juge's group in the Quadram Institute then, at that point, utilized the results of this aging to contemplate the impact of aged HMOs on the intestinal hindrance capacity of cell lines and progressed gut-on-chip models. CACO2 cells are a line of cells initially got from the human gut and utilized broadly in research, with a course of action of them into a solitary layer being a setup model for considering the gut and its porousness. Restraining necroptosis could be a novel methodology for treating COPD. Examination distinguishes SARS-CoV-2 holes as potential medication targets. New strategy can gauge metabolic cycle at the single-cell level. A critical decrease in porousness was noticed utilizing CACO2 cell monolayers with matured HMOs, joined by an increment in explicit proteins known to help keep up hindrance respectability, tight intersection proteins and cytokines. While these outcomes are promising, they actually should be converted into research in people. However, considering the collaborations at the phone level inside the gut is exceptionally troublesome. To evaluate the interpretation of the discoveries to people, the group utilized progressed in vitro models of the human digestive organ created by Emulate Inc., a bio-innovation organization situated in Boston, USA. They had practical experience in organs-on-chips innovation, a human cell-based innovation that reproduces organ-level capacity to demonstrate organs in sound and unhealthy states. The intestine chip is a miniature-designed stage permitting the co-culture of epithelium cells that make up the gut, fixing with tissue-explicit microvascular endothelial cells under microfluidic conditions. This approach, spearheaded by Emulate, reproduces the cell microenvironment, including tissue-to-tissue interfaces, media stream, and mechanical powers, like stream and stretch. Through a BBSRC Flexible Talent Mobility account granted to Dr. Tanya Sulagoj in the Juge Lab, A gut-on-chip framework has been set up in the Quadram Institute to help translational investigations of the gut. In a joint effort with the Norwich Research Park, NRP, Biorepository and the Norfolk and Norwich University Hospital, NNUH, human intestinal biopsies from sound, consenting grown-ups were utilized to create organoids. Organoids are self-coordinated bunches of cells that develop to repeat tissues of organs. For this situation, the proximal, crossover and distal locales of the colon. These were then cultivated on chips to create colon-intestine chips, which were refined under microfluidic conditions to reproduce the design and capacity of the intestinal epithelium. Utilizing this framework, they showed a critical increment of certain tight intersection proteins across each of the 3 gut-on-chips following treatment with aged 2-FL. Taken together, these information showed that as well as supporting bifidobacterial development and a solid microbiota, HMOs have the ability to balance resistant capacity and the gut boundary, supporting the capability of HMOs to give medical advantages in grown-ups.